Thank you, Patrick. So last year there were over 10,000 peer-reviewed papers on using deep learning and AI for medical imaging segmentation and classification. Our quest is to bring the reproducibility we've developed within Odyssey to the imaging research world, and also bring all the fantastic features that are being developed in imaging research into clinical outcomes research. So next slide. I'm really pleased to lead this committee with Chan at Yonsei University in Seoul. We have a great group, and the way we're doing that is we basically have built. We started in 2021. We built an imaging extension over about 2 years of consensus building within the Odyssey community about how to build standards and conventions for extensions within Odyssey, and we have basically one table to map source data for medical imaging from DICOM, and another table to track all the imaging features that we create from our segmentation algorithms. And so we developed that. We actually published that paper in February of 2024. Next slide. And that paper has already been accessed over 3,800 times, has already been cited 8 times. It's actually been implemented by 3 vendors already, including Microsoft on their Azure platform. So we're really excited to seeing the uptake of imaging research and how we can really bring reproducibility to the field of imaging. We actually have our meetings at 7 a.m. or 7 p.m. alternatingly on Wednesdays, and we do that really to be inclusive of both our colleagues throughout the world. And so we have it for European as well as for our Asia Pacific colleagues, and we found that to be a great way of bringing our communities together. So we are continuing that. We now have over 200 members of our imaging working group, so it's an open working group. We encourage all people to attend, and this year's gonna be really exciting. If you go to the next slide, we've done a lot in the last year, but I want to go to the next slide for what we're up and coming to do now. Now we're actually doing, so skip one more slide, and this is our final slide around, here's what we're doing now is building reference implementations for how to do this on real world data. We've actually done this on large clinical registries like the Alzheimer's Data Network Initiative, and now we're implementing this at right now 3 medical institutions, and we're trying to develop all the common guidelines and conventions for how you handle DICOM global unique IDs and map to accession numbers, to procedure occurrences, to order IDs, and then also trying to figure out where we want to build conventions. So there are actually over 1,000 pieces of metadata for every DICOM image. Some of them are very useful, like spatial characteristics, like the resolution of the image, or the contrast characteristics, like which describe the imaging physics around it. But there's also a ton of other fields, and so we could literally have 1,000 DICOM measurements per DICOM study, and that would actually increase the already overburdened measurement table as it is. And so we're trying to figure out ways, or what's the right conventions to make useful for most patterns of medical imaging research. And so our goal this year is going to be focusing on reference implementations in the real world, as well as education on how to make this implementation as straightforward as possible. We've submitted our 3rd paper already. Our first paper was on the structure of imaging extension, and our 3rd paper is on the semantics of the vocabulary needed to be able to incorporate this into the OMOP data model. And our 4th paper is how we're using this to replicate research within the ADNI data network. And then we really would like to put together a software guide for how to do ETL harvesting of DICOM data, and also hopefully contribute to the Book of Odyssey and raise awareness. We're really excited by the NEI last year and how much they've aligned with medical imaging research with Odyssey with their NEI challenge grant. So we're really excited about the potential for really accelerating research in the imaging space. Thank you, Patrick.